question. So this one's about graph, apparently. Let's read it. A robot is located at the top left corner of a n by n grid. Okay. The robot can only move at the down right at any point in time. The robot is trying to reach the bottom right corner of the grid. Okay. Now, consider some obstacles are added to the grid. How many unique paths would there be? Okay. Obstacle and space 0, 1. So yeah, let's do something like this. That'd be 0, 0, 1, 1, 0, 0, 0, 0, 0. I'm trying to start from here, and bottom right is the end point. Okay, we're starting from S to E. So 1 is obstacles, right? And we're asking how many unique paths would it be. So yeah, definitely we can do. So we're counting the path. So a search-based algorithm, we can do, for example, DFS or BFS. We think about DFX. How is the DFS gonna work here? There's a 2 paths apparently here. So that changes to 0 would be like 1 path, 2 paths, 3 paths. I can only go at the down or right, so it would be 1, 2, 3, 4 paths. So the way I'm gonna approach this would be like how many. Yeah, so BFS, DFS. The problem is that it could spend of number of path time. It could be something like exponential, right? So the second solution will be count with dynamic programming. So it's quite straightforward to know that the number of path arriving at ij will be number of path of I plus 1j, and add number of path with ij plus 1. It's like this one path going here. If you are at this position, you can choose, like, let me give a draw. For example, if you have one path here, you have multiple paths here, you don't actually have to rerun the path again, right? You don't have to do it again for those 2. You just have to add the number here. So that's the secret of DP. We can actually do it in search. Can we? Let's see. No, we cannot. I think if we can do BFS, because that first search, I just run to this straightly. But with BFS, I think, yeah, potentially you can do that, because you're going one round and another round. Right. There's obstacles here. Can you arrives here directly? Because there's no other way to go around to be at the same location again, right? Because we're just going down and right. So you can potentially do that. So it'll be N and M, I think. You can do that. So we're doing DP, it's already N and M. In time, space is essentially the same. Can we optimize the space? Well, we're doing the last line and this line's second, so we're always updating node from this and this. Let me think. Can we get rid of it? Yeah, I think supposedly I can with the order. Right, I can do it. Or I can just do like a rolling basis. So the space will just be O of M. You can do it backwards, just do like, right? And if you care so much, you can even do min of O and M. Okay. Yeah, so let's code. We need vector for graph. And yes, essentially all we need. So we're using namespace for simplicity, and I'll define a solver for this question. And there's just one function that is get number, and we return int the graph can be represented as a 2D array. That is graph. Yeah, and start it from the top left. So do some initialization. N will be lines. Graph size. M is graph 0.size. Let's assume it's a valid graph, okay? And we have my number vector. Number vector will be like M, right? Yeah. So let's just do the rolling basis. So it'd be 2 and the vector of M that initially just have 0. And yeah, and the number 0, 0 be 1. Okay. Calculate this. So the way we're doing it is using 2 loops. So we now have the obstacle. So if graph ij is some kind of obstacle, right, is 1, then we don't do it. Else we're doing this. So because we're doing rolling, one technique would be doing 0 and 1s. So we add 1 instead of -1. Okay. So we're just doing it in I, yes. Yeah. After we've done it, I just return answer. Return number. Last line will be n-1, so n+1 mode 2. And the last line will be m-1. So let's be careful. If it's 0, we should return -1. There's no row to it. We're just doing this. We'll be fine. So I'm adding my test case. It would be something like this. 0 1 1 1 0 0 0 0 0 1 0 0 0 1 1 1. Now it's like 0 0 0 0. Also 0 1 1 0 0 and 0 0 0. Yeah, so it'd be test case. Just using the graph. Got a solver. Okay. We'll do wrong. 75, 58. Okay, 58. -1, mode 2, mode 2. Definitely mode 2, right? Okay. Okay, let's do 58. J would be my, this would be 2m. Right? Yeah, it should be 2m. So I'm trying size. Four, 2 3 4. Totally agree. And we're doing I and J. Zero zero. This is 0 0 -1. Oh, yeah, sure. So let's see. If J is 0, if j is 0, we shouldn't do -1, right? But we're using rolling basis. We don't need to care about it. This number is 0. We have 0 way of getting it. If j is 0, we should add this one. So j is not 0, we're adding maybe we should try a different, like 0, 0 and 0, 0. If it's 1, we continue, or else so not doing the first row will be, so we should not doing from the first row, right? No, we should not do from spare the first. So if I equals 0 and j equals 0, what we do is we just continue. A better engineering way to do this is like just initialize the first row and first column, right? I think it's the right way to go. Maybe 2. Okay. So about the example here, we should do four. Yeah, that's right.